Hello ELT132, this is Roger Young, and now we're going to start on the first video on flip-flops. So the prior three videos in this section dealt with latches. So at the last part of the last video, I said the difference between the latch, how we're looking at it in this course, is a latch which has the enable connected to a clock is a flip-flop. So now, if you look at the D flip-flop, which is what I have listed here, this is the symbol for a D flip-flop. What do you have? You have a D input, you have a clock input, and then you have a Q and a Q bar. All right? So, in the top part, this just shows you the latch, the D latch, which you looked at before. However, I think that's termed the transparent latch. However, now we have an edge detector circuit. In other words, so when you have a clock pulse, in this case, it's going from low to high. You have a rising edge. That's going to cause a pulse to go through and enable it just for that instant of time, right? It's a very short window when that's going to be active. But when that pulses, it's going to look at the input at D, right? So when D is 0, Q is 0. When D is 1, Q is 1. In other words, Q follows D. Remember that. This is the D flip-flop, and the enable is connected to a clock, and you have an edge detector. And when you're looking at, when you're going to look at a truth table, they're going to show things. I'm sorry, I have to click on that again. They're going to show things like this. If this is your D input, whatever it may be, and they're going to show your clock. Usually your clock can be anywhere in there. Sometimes it's first, sometimes it's not. But they're going to denote an edge signal by an arrow. All right? Specifically, if this arrow is facing upwards, that's denoted as a rising edge, okay? Now, on another flip-flop, suppose you have this. It's going to be edge detected, but it's going to be on the falling edge. Now notice how they depict this. Do you see the rising edge? If it's rising, excuse my handwriting please, but the rising edge, if you have an arrow like that, that means it's starting low and it's going high, and sometimes you're going to see like a little arrow right there. That means the rising edge. Alternatively, right, we could basically write a falling. I'm sorry, I have to click that again, right? I can write a falling edge the same way. I guess I just hit the old delete key here. There we go. So if we write a falling edge, that's going to be depicted by a down arrow. That's going to be depicted by this. And that's a down arrow, as this was an up arrow. These may or may not be listed. They're not shown here, are they? It just shows you a rising edge pulse, but they're just looking for that edge. That's when it's going to pulse the enable, and that's when it's going to look at it. And if you recall from our prior discussion, right, where I showed an enable pulse coming through, and I said it was on maybe for 10 seconds or so, and 1 second it was on, 9 seconds it was off, if the period was that, for example. In other words, I just did that mistake again, didn't I? walking and chewing gum, rather difficult, you know. So if your pulse is like this, right? This is what we had for the latch. And this time here, between this time up and this time up, this was your period T, right? Between these 2 points. In this distance here, from this side to this side, this had a width, right? It could have been whatever we wanted it to be. It's however long you wanted to enable it. But what we're saying with the edge detectors, this is very, very short, extremely short. And it might only look like it's a very, very short pulse when it goes through. But the operation is just the same. It's just going to look at it at a specific point in time, and then it's going to see what your D input is, and it's going to be transmitted to the output. I hope this video has been helpful to you, and thanks for watching.